Dr. McMillan.
Dr. McMillan? Oh, I bet he can't hear us. Like.
Well.
Let's text someone in class.
Okay.
Wait, I guess they wouldn't. Katrina? Dr. McMillan. I just see his hands. McMillan. We can't.
We can't hear anything.
Can you all hear me?
Yeah.
All right. Were you not hearing me before?
Yeah, we couldn't.
All right. I wasn't on mute. It's a speaker thing. So what I was saying before was that water and hydrogen peroxide are two different things. One's H2O, the other is H2O2. There's a pretty horrible joke about someone ordering H2O2 after someone else orders water and dies because they're very different. So here is a test tube that was made a few years ago that has water in it and something called manganese dioxide, which is just a black powdery ionic compound. There's nothing really to worry about it besides it being called manganese dioxide. And this does not dissolve, does not react, does not do anything with water. Here, I've got 30% hydrogen peroxide. This is 10 times as concentrated as the kind that you get out of the drugstore for putting on cuts. This is the strength that you use to intensely bleach somebody's hair. Okay. And it's very dangerous. That's why we're wearing gloves. Oh, and I should be wearing goggles because this could put your eyes out. Okay. Yeah. You're happy about this, aren't you? Okay, so what do y'all notice about this jar or bottle? It's brown.
Oh.
It's opaque. What's that suggest? When you get it, when you buy hydrogen peroxide in the drugstore, it's brown and opaque, just like this. Whereas if you buy rubbing alcohol in the drugstore, it's in one of those translucent plastic bottles like this.
Does it evaporate?
Well, it doesn't evaporate because you got a cap on it, but sunlight will actually break it down. I wish I can't do all this. I wish that I had like a holographic screen I could put up and draw or something. But if you think about it, H2O2 means hydrogen connected to oxygen, connected to oxygen, connected to hydrogen instead of hydrogen, oxygen, hydrogen. And that oxygen-oxygen bond is not super stable. So what hydrogen peroxide tends to do is spontaneously, very slowly break down into just water and oxygen. So H2O2, arrow, H2O plus O2, not balanced. So hydrogen peroxide, not stable, wants to break down, decompose into just plain old water and some oxygen. And so even sunlight will make that happen. So they put it in dark bottles to keep sunlight at it. That's why it has an expiration date. Most things that you get out of the drugstore have expiration dates that don't really mean anything and aren't all that important. Say like aspirin or something, or ibuprofen. They have expiration dates on it, but as long as you've kept them cool, dry, and in a dark place, they probably would last for forever and would never break down. This, however, actually does break down. So as soon, from the time it's been manufactured, it's continuously, very slowly starting to break down just into plain water and oxygen. When we used to buy this, it actually would come in an accordion bottle. So it was like a springy bottle, and that was there to accommodate it continually expanding as oxygen was released from it. Now they just give us a bottle that's only about half full. I guess it's because it's probably cheaper that way. So you can, however, speed that slow decomposition reaction up by providing a catalyst. You all have probably seen this on YouTube. Has anyone ever seen the elephant toothpaste reaction? This is the basis of it. You add something that makes the reaction happen easier and it goes faster. And so now you make a lot of oxygen fast rather than very gradually. If you add soap to this before the reaction happens, then it makes a lot of foam, and that's what the elephant toothpaste reaction is. We're going to do a variation on it. A lot of times people doing it at home use yeast because yeast is an organism that makes a compound that naturally breaks down peroxide. There's many things. I mean, hydrogen peroxide wants to break down. There's a lot of things that will just tip it over the edge and make it react. Compounds or substances that don't take part in a reaction, but do make that reaction happen faster. Anyone have an idea what those things will be called?
Is it a catalyst?
Catherine, let me see if I can try to make it so I can hear you. Put it in the chat, maybe.
Nope.
Yes, catalyst. So a catalyst is something that helps a reaction go faster, but doesn't actually take part in it. So turns out manganese dioxide, this powder that does nothing to water, is actually a catalyst for the hydrogen peroxide reaction. All right, now here is where Leah comes in. You're going to help set this all up. So first thing you're going to need to do is fill this about half the way with hydrogen peroxide. Let's go over how to do that. Funnels don't work well if you hold them all the way against the lip because you make a vacuum. So hold this a little bit up like that. Also, pretty much, I'm going to get a bigger test tube than this because this is a little bit lumpy. The other thing, yeah, that looks better. The other thing is that it's hard to gauge how much is still in the funnel. So pretty much tip some in and then turn it back over and wait and see and let the funnel fill it up and see if you need to add more. Does that make sense? Yeah. Okay. So there you go. That's probably good. All right. So set that back down and make sure that you put the cap firmly back on the bottle and set it over there to the side. I have no idea what that was. So you can see this is already bubbling a little bit, which means that this test tube probably wasn't super clean. So there might be something in there that's interacting with it. But we're going to see what happens when we add a catalyst to the reaction. So what you're going to do is just dip out about that much. Tip it in, and then this tilts. So you're going to tilt this away from you as soon as you add it to it. That's why we have the big blast shield there. Okay. Maybe just a smidge more. It's not real exact. Yeah, that's good. Okay. Sweet. Right. So we're going to see what's in this vapor that we're making. All right. This is paper that turns pink in the presence of water. Hold that into that cloud and see what you get. Maybe closer to the mouth of the thing. Yeah. All right. Pull it out. It turned pink. So that's water vapor. Touch the test tube at the bottom. Still warm? Yep, it's warm. Next thing we're going to do is try. Yeah, it does. It's still going. All right. Now stick this inside the tube. We may need to. Oh, no, that didn't do anything. All right, we're going to do this again. All right, so here's add a smidge more peroxide to it. It finished reacting before we got finished with everything. Ugh. Funnel got all bleepy. Let's here. That could start reacting before you. Good. Let's fix that off as well. Actually, there's funnels straight back that way in that cabinet. I'm afraid that this one might cause a bad reaction. If you could get a clean one. Thank you. And just a glove. Awesome. I'll want this again. Huh. Catch on fire. How does it catch on fire? Okay, so I got this. I'm gonna okay. So now it's stick this, just don't drop it in, just stick it. Don't stick it in the liquid is what I was trying to say. Let's do it one more time. Oh. All right, so just stick this in the mouth without dropping it in, and it should get brighter, if not catch fire again. Maybe there's too much. Can you see it getting brighter? Pull it back out and stick it back in, and let's see if it's not as great as I was hoping it would be. Can you get it closer down to where the bubbling is without pulling it out? So we've got warring things here. We've got the water bubbling up and not. All right, well, this wasn't a super great reaction, but this is actually a pretty common technique in chemistry to test for the presence of oxygen. Literally, you just put something that's on fire in and see if it catches fire better because you're making lots of oxygen. And we were, but it wasn't the greatest. Okay, great. Let me help you. Now I need to take this. So everyone can take your seats, and I'll have to clean this up later. So while I'm cleaning this up, everybody, oh, that's a good question, Grace. Is it not catching fire because of the water vapor? Yeah, that actually was part of it, but it does, usually when I do this, it makes enough oxygen that it actually either lights the splint back on fire or at least makes it glow brighter because it's putting pure oxygen into the air. Remember that air is normally just like 20% oxygen. So, awesome. So try to write down that reaction and balance it while I'm getting myself settled again. Catherine?
I don't know if you can hear me.
Here, I'm gonna try to see if I can hear you again. All right, can you try saying something?
Hello.